Hi gang, today we're going to try to figure out how to solve a problem like this where we're dealing with either complementary or supplementary angles. First of all, we notice that there is a straight line going across the bottom of what looks to be one, two, three angles here. Here's your one angle, here's your second angle, here's your third angle. And the straight line here tells us, well, let me get the straight line tool instead. Where is that little guy? There it is. And the straight line here tells us that it is supplementary. Now we know that supplementary angles always equal, that's right, always add up to 180 degrees. Cool. So we're given parts of these three angles, or values for these three angles that will help us to discover what the missing link is to this problem. All right, so far we know that two of them are 40 degrees. So if we just added up the two 40s and this 30-degree angle here, and don't forget the 2x, all four of those values add up to 180 degrees. So if we added up the ones that are given, the 40, the 40, and the 30, 40 plus 40 is 80, plus another 30 is 110 degrees. That helps us to create, or to further help solve this algebraic equation. Now to solve this one, we know that 110 degrees are already taken care of from this 180. So algebraically, we can show that 110 degrees are already accounted for just by taking 110 away from 180. We find that this 2x here, that 2x is actually 70 degrees. This 2x equals 70 degrees of the missing angle here. Now, we know that 2 times what number? 2 doubled. I'm sorry, what number doubled is 70? Well, we can figure that out just by dividing 70 by 2 to find that x is 35 degrees. Now, of course, we may have made a mistake somewhere along the way, so we can always check ourselves out. Just we know that supplementary angles always add up to 180 degrees. So if we took that 35 degrees, and if we doubled it, that's the 2x piece of this equation. If we doubled it, we'd end up with 70 degrees. Now, don't forget the other parts. This 70 plus the 30 degrees equals 100 degrees. Now, in addition to that, we had two 40-degree angles that were accounted for. The two 40-degree angles account for an additional 80 degrees. If we add all that up, we end up with our 180 degrees. That proves to us that x was 35 degrees all along, because they all add up to 180 degrees, supplementary angles. Let's do one more. Beautiful. Now, in this diagram down here, we do see that, yeah, there is, here, let's use the straight line tool again. That came in handy last time. There is a straight line here, which indicates that this, this one angle here, plus the second angle, plus this third angle, which is indicated by 90 degrees, they all have to add up to 180. However, we know that the definition of, type it out, this is handy. We know the definition of a couple of angles. It doesn't matter how many angles there are, but in this case we have two angles that have to add up to 90 degrees, because we know that 90 degrees here plus this 90 degrees here would equal the full 180 degrees that go across the entire line there. All right, that being said, did I lose my font size? I did. Here we go. That being said, okay, these are complementary angles. Hope that doesn't show up. Complementary angles are angles that add up to 90 degrees. Okay, so these two angles, here we go, the 20 degrees plus the 6x minus 2 degrees. Now they give us an expression, 6x minus 2 degrees. That indicates what the other full angle is here. It's up to us to figure out what that missing link is there. But those two angles all together have to equal 90 degrees. Let's go to a different color here. All right, what we can do is we can add together the like terms that are on one side of our equation here. We have 20 degrees, and if we subtracted 2 degrees from it, we'd end up with 18 degrees. Now don't forget, we still have the 6 times an unknown degree measure. Both those two angles still have to equal 90 degrees. Now, in algebra, of course, we all recall that the next thing to do, since 18 degrees are accounted for, of the 90 degrees, we could subtract 18 from both sides of our equation. Let's go to a different color. All right. Now on the left side of our equation, since we subtracted 18 from 18, these no longer have to be there. Why don't we just go back one? Does this do it? Undo. Yeah, there we go. It's all coming back to me now. All right, so if we just subtracted 18 from 90, we could borrow from 9, make that an 8. So 1, sorry, it's a little messy. 10 minus 8 is 2, and 8 minus the 1 is 7. Now we just have to figure out, through division, 6 times what is 72? Oh, we could just divide 72 by 6 to find that x is 12. X is 12. Now, of course, I mean, you're not going to just take my word for it, right? You're going to check this out to make sure it works. So since these two angles here, the 20 and the 6 times 12 minus 2, they have to be, they're complementary. They have to add up to 90 degrees. You're going to take your 6 and multiply it by our new x value, 12, and then we'll subtract 2 from it. But of course, we'll add 20. And what should we get? That's right, we should get 90 degrees altogether. Okay, cool. So let's take care of this. Of course, we remember order of operation, where multiplication has to come before any subtraction or addition. So let's go ahead and multiply 6 times 12. Well, 6 times 2 is 12. You can carry the 1, and then 6 times this 1 is 6 plus 1 more is 7. There's your 72 minus 2 plus 20. Hey, does that equal 90? There's a little question mark there. Does that equal 90? Well, let's take it to the next step. 72 minus 2, that is 70. And then when we add 20 to 70, it becomes so apparent that 70 plus 20 is 90. It checks out that x must be 12 in that case. So there's a couple examples there. Hopefully that helped you out a little bit if you were stumped by the supplementary or complementary angles and trying to figure out what the missing value of x was. I hope you enjoyed the video. Now I got to figure out how to